In this video, we are going to learn how to solve trigonometric equations quadratic in form. Now, I first want to start off with how to use the zero product property in order to use this technique. So if we have two factors being multiplied and they're equal to 0, we can set each of those factors separately equal to 0 in order to solve. So in the case of this first example, we're going to set tangent of theta minus 1 equal to 0 and secant of theta minus 1 equal to 0. And then I can add 1, and I'll get tangent of theta is equal to 1, and secant of theta is equal to 1. And on the right, I know secant is the reciprocal of cosine, so I can rewrite this as cosine of theta is equal to the reciprocal of 1, which is still 1, and now I have two equations I need to solve. Now, for these problems, we're solving each of these equations on the interval 0 to 2 pi, so I just need the angles that are on the unit circle for these particular trig functions. So where is tangent of theta equal to 1? That would be at pi over 4 and at 5 pi over 4. And where is cosine of theta equal to 1? Well, this happens at 0 and at 2 pi. But I'm not going to use 2 pi since it's not inside of my domain. So I'll just use 0 for this solution. And these three angles would be the solution to the equation. Now, let's say it's not set up in factors yet, but you can still factor out a common factor. In this case, both of these terms, 2 cosine squared theta and cosine of theta, both have a cosine as a factor. So to start out the function, start out the equation, I can factor out cosine of theta. And I'll be left with 2 cosine of theta plus 1 in parentheses, and that's equal to 0. And now I have my two factors being multiplied equal to 0. So now I set cosine of theta equal to 0 and 2 cosine of theta plus 1 equal to 0. I solve the equation on the right to get cosine of theta by itself. And I get cosine of theta is equal to negative 1/2. And now I need to list out all the solutions that follow both of these equations. Now where is cosine of theta equal to 0? That would be at pi over 2 at the top of your unit circle and 3 pi over 2 at the bottom of your unit circle. So I'll put pi over 2 and 3 pi over 2 as solutions to the left equation. And for the right equation, I will have two solutions as well, because cosine of theta is equal to negative 1/2 at 2 pi over 3 and at 4 pi over 3. You'll see that's just left of the x-axis. It's the uppermost angle in the second quadrant and the lowermost angle in the third quadrant. So we get these four solutions to our equation. These are the angles that are on the unit circle as indicated by our domain. Now let's say we have three terms, but they don't have a factor in common, but they are quadratic in form, meaning there is a squared term, a non-squared term, and then a constant. So what you can do is you can think of this problem as 2x squared minus 3x plus 1 equals 0, where x is equal to sine of theta. And then factor this equation, and it works the same as if you would have had the sines. And just to show this, factoring this equation here, we have to find two numbers that would multiply to a positive 2 but add to a negative 3x, which would be negative 2x minus x. That's how we split the middle term. And then using grouping, I can get 2x times x minus 1. I can factor out a negative 1 there and get x minus 1. Leave me with the factors x minus 1 times 2x minus 1, which is how this equation will factor as well. And you can follow all the same steps, just switching out all the x's for sine of thetas. But in my case, I'm just going to rewrite this as theta, sine of theta minus 1 times 2 sine of theta minus 1. And then I'll continue to solve. So I factored it like a quadratic, and now I'll set each factor equal to 0, since that's what it's equal to. So sine of theta minus 1 equals 0, and 2 sine of theta minus 1 equals 0. The equation on the left solves for sine of theta equals 1, while the equation on the right solves for sine of theta is equal to 1/2. And now I'm looking for where the sine of theta equal 1. Well, it's only at one spot on our unit circle, at pi over 2, which is the very top of our unit circle. Now for the next solutions, where does sine of theta equal 1/2? Well, this happens at the far rightmost angles in the first and fourth quadrant, which would be pi over 6 and 11 pi over, not 11 pi over 6, it would be 5 pi over 6. The lower angles in the first and second quadrant, actually. That is a 6 here. A little flub by putting a 2 on accident. So pi over 2, pi over 6, and 5 pi over 6. Now for the last example, I have 2 cosine squared theta plus cosine theta, which I had on the left here, but instead of being equal to 0, it's equal to 1. So if it's not equal to 0 yet, but you see this quadratic forming, then we need to move everything to one side, because if you were to factor this, it would be still equal to 1, which doesn't follow the zero product property. So I need to subtract 1 first. So I have 2 cosine squared of theta plus cosine of theta minus 1 equals 0. And now I'm going to use that very similar technique. 2x squared plus x minus 1 equals 0, which just means that x is equal to cosine of theta. And I'm just going to factor this like a normal quadratic, meaning I'm going to find two numbers that multiply to -2 while they add to a positive 1, which is going to be 2 and -1. 2 times -1 is -2, and they add to a positive 1 in the middle. Factor out the common factor, I get 2x times x plus 1. Factor out a -1, I get another x plus 1. And I have one factor of x plus 1 times 2x minus 1 equals 0. So my quadratic up here factors into cosine of theta plus 1 times 2 cosine of theta minus 1. Set each factor equal to 0. Solving both, I get cosine of theta is equal to -1, and I get cosine of theta is equal to 1/2. Again, where does this happen on our unit circle? Cosine of theta is equal to -1 at pi, while cosine of theta is equal to 1/2 at pi over 3, and at 5 pi over 3 in the first and fourth quadrants, where cosine's positive, and it's that angle that's the uppermost and lowermost because it doesn't go over as far. And we'll end up with these three solutions: pi, pi over 3, and 5 pi over 3. And that is how you solve trigonometric equations quadratic in form.